Yeah, so let's get started. First of all, I'm DG. I'm glad I'm here. I want to thank everybody for staying for this last presentation of the workshop. I'll promise I'll be as quick as possible. But my goal today is basically show you some examples of CI/CD that we worked with back when I was in Belgium on a course that we had. So I was in a lab where we were doing basically developing CFD codes, and there was some need for CI/CD at some point. So I'm going to show you what we did for that. Before I go any further, I'd like to acknowledge my colleagues, Pierre Balti and Thomas Gillis, who were of great help developing the content in this presentation. So yeah, let's jump into it. So there's going to be two examples of CI/CD. It's not going to be anything really complex and as sophisticated as what you've seen in the past presentations, but really, I just want to emphasize some of the GitLab functionalities. As a matter of fact, everything we did was with GitLab, so it's going to be kind of complementary with the things that Olivier has presented earlier today. And as much as I can along the way, I'll try to share some lessons learned, or at least tips and tricks that we determined when developing the workflow, and that maybe can be useful for you as well. So the original needs for us, so we were kind of a small group of developers working on some codes, and there was this code in particular. I'm just showing here the history of the commits of that code, and you can see, so basically there's a lot of people working on that code at some point in the time, and that's why we kind of really felt the need for having some ways of testing. And so it's that code was kind of a legacy code, so it was not really developed with regression testing in mind, but at least we wanted to be able to build automatically the code and basically prevent anybody from pushing to the master something that would not be compilable. So that was kind of the first need, and that's going to be my first example here. And then there was other codes that we started developing and where we wanted to have some more testing capabilities implemented there, and that's going to be what I'm going to talk about in the second example. So in these two examples, there's going to be some HPC involved, and I'll try to focus on that in the presentation. So yeah, let's move on to the first example. So the code is called VPM4X. As I said, it's a legacy code. It's a research CFD code that's been around for like more than 10 years. And what we wanted to do here basically is to be able to automatically build the code, but with different compilers. Now, one of the challenges that we had is that we wanted to test 4 different compilers, including the Intel suite, which for us was only available on the HPC environment because of licensing issues. So that was kind of the first motivation for us to kind of develop a solution that would interact with the cluster. So what we did is something relatively simple, but in terms of pipeline, so whenever the pipeline is triggered, you will have your local runner that would connect to the front end of the HPC, where you would receive the sources, the source files. They would be compiled there, and then basically you return a flag to say, hey, the compilation succeeded, or hey, the compilation failed. So nothing too fancy here, but we were able to set up that connection that we needed to have access to all the compilers that we would use in production. So really one of the big advantage of doing so was that basically we were able to test in our production environment. So remember the small meme that I had on the first slide. So I agree, it might not be the most long-term viable solution, but for us that was really convenient, because basically whatever you test with GitLab, then you were sure that the same code would run on the same production environment, and that was a big relief for us to be able to do that automatically. So Yeah, I don't think it's the best solution, but it's not very portable, and it needed some support from local admin, because basically the way we handle the connection is through a specific user that had to be created for that. And that has led to some maintenance issue, but well, nothing too bad. But I would say, so this is a solution that's great for a small number of people working in a small research group on a limited number of codes, and that corresponded to what we were doing. So we were quite happy with that solution. Yeah, so that was kind of the first step. Now the second step was that new code that we developed. It's called FLUPS. It's basically a math library written in C and C++ to solve the Poisson equation. And so we started that development from scratch. So we really had the freedom to do a bit more, and we felt like it was a good time for us to try and implement some regression testing in addition to testing for building the code. So I'll try and show you how we did that, and then I'll open GitLab and show you some of the features that we have there. But basically, the idea is we still have like a first stage where we build the code on the supercomputer. Now, the small difference we have here is basically from the build, we create an artifact that we will be able to reuse for our runs. So that's the first stage, building, similar to the first example. And then now we have a stage for regression testing. And the way we handle that is a bit different than what Olivier presented earlier, but we do that with two separate jobs. So let's see how this works. So when the build is completed, you go to the next job which would connect to the cluster, transfer the artifact so that you can run the code that you compiled before. And basically, the first job here is just going to submit jobs into the HPC queue. Obviously, we don't want to run anything from the front end. So the trick here is how to handle the fact that you're going to have jobs in the queue. So so this first job submits jobs. So obviously, you will have to wait a bit for your jobs to start, and then you're going to have to wait their completion. But when the first job is done, then we run a second job that's going to basically connect to the cluster and just poll the HPC jobs and check whenever they're finished. So it's going to do that a couple of times until the jobs are done, and then retrieve all the information that you want to have in the end passed to GitLab. Now, one of the nice feature that we have developed here is through the Google test library. So basically, you know, when you do a pipeline, the default solution is just to return a flag to say, hey, something went wrong or everything went fine. And it's not a very detailed information. You just know something went wrong or it went fine. So in order to have kind of more information about the jobs themselves, we worked with the Google test library, which basically provides some support to define tests in your code, and that gives you the ability to generate some reports with metrics related to your code and how your code performed. And the good stuff here is that basically the reports that Google Test outputs, it's an XML file that GitLab can interpret. And so basically when you pass back this file, you will have much more information available directly from the web interface in GitLab about your pipeline. So I thought that was kind of cool. So now, if you want to take a look at the entire pipeline that we have for this code, you have something that looks like this. Just in terms of definitions here, so I'm sure you heard of that earlier today, but basically, so we work with stages. So we have like, in this case, 4 stages. The first stage is the build stage, where you have all the jobs that we have here to compile the code with different options and different compilers. And then we have a stage where we do some testing. basically just making sure that everything can run. We do some validation, which is basically part of the regression testing, and the things that I just presented with the connection to the cluster are in this last stage. So I'm gonna exit the presentation mode for a second and just show you what it looks like on GitLab. So this is the summary page of all the pipelines we have. I'm gonna just open one that passed here. And we're gonna see exactly the same picture that I was just showing. So yeah, same thing here. Let me just open real quick one of the tests here. For example, I'm opening this one that was basically the one that connects to the cluster and does the compilation. And well, it's pretty boring, but you see this, basically you see all the outputs and you can do some troubleshooting by just looking at those logs, even though it's not super fancy. But at least this is what it looks like. So this is the job that's gonna compile the code on the supercomputer. Now let's move on to these last two, and these are the jobs that submit the jobs to the HPC facility and then retrieve the results. So looking at the output is maybe not the most insightful, but we can at least open the code, and I'll show you some features there. No, that's not what I want. Okay, so you know that everything pipeline related on GitLab or GitHub is working through that YAML file. So on GitLab, it has this name. So let's just open it. So this is actually where you define all the stages that you have in your pipeline. I'm going to go through some of these features, obviously not everything in detail, but okay, I should open another branch, I believe, if I want to be thorough here. Okay, so again, so same file where you define the stages. I want to emphasize this bit of code here. So this is in the general YAML that defines everything. The thing is, since we're going to interact with the cluster, we're going to do that through SSH commands. And so upfront, we need to define some things so that the SSH command can run easily, can run at all. So this is something that we do here through that before script keywords. So basically, it's before any pipeline is run, the runner is going to execute that bit of code, and this is where we basically configure the everything related to SSH. So basically, we create a SSH config file. The nice thing about GitLab is it lets you use variables. So for instance, this line, this is where we set up the SSH key for all the communications that we will have with the cluster. And obviously, you don't want to have your SSH key exposed in a commit on your open source code. That would be kind of a major security issue here. So you can use those variables, and they're basically defined in the settings of your repository. And so you can hide them for, let's say, anybody that would look at your code. And this is something that you keep for yourself, but at least it enables everything SSH-wise. Okay, I'm going to open another file now just to show you how we worked with the HPC related YAML file. And so this one is the job for the compilation of the code. Then more interestingly, the second one is the one that submits the jobs on the HPC. And you see, it's not really too complex. Basically, it's like 6 commands, and basically we end up doing a submission in the queue on the HPC. And the last job I was talking about is the one that is going to check for the results. So we're going to have basically a while loop that is going to just periodically check if the jobs are completed. And when they're completed, it's going to retrieve the information that we want and pass them back to GitLab. Now, talking about that information and the tests, the results of the tests. So when you go back to your pipeline, you can open this one, for instance. So you have the global view of the pipeline, and in this interface, basically, it just tells you, okay, this job completed or this job failed. Now, I was talking about those tests that give you a bit more information. Well, basically, if you go under the test tab here, because we have this ability to read the reports that the test generated, we can have more information in this tab. And basically for each test that we're doing on the supercomputer, then we'll have some data available here. And basically for a test that failed, you'll know the output, and maybe you will be able to determine why the test failed. And also you have the duration of the test, which is sometimes meaningful when you try to debug anything. So yeah, maybe one last thing. I'm going to talk about that in a minute, actually. Let me go back to the presentation. Yeah, so so for the rest of this presentation, in the last minutes I have, I'll just try and show you some of the nice features that you can use in those YAML files to make it easy for your workflow to do whatever you want. One thing I wanted to talk about is the trigger condition. So in a lot of cases, you don't want to run the same pipeline in all cases. I mean, if you have a pull request or a merge request in your code, maybe you want to do some more extensive testing that whatever you would do for a regular commit in a random branch. Okay, so this is something that you can do. You can differentiate what pipelines will be run for what case, and you can do that in two ways. So there's the only and the except keywords that you can use. The problem with that is you easily end up with conditions where one single pipeline will be triggered multiple times for the same commit. And here, for instance, I'm trying to run a pipeline for basically a merge request and any commit. But for any commit on a merge request, this will be triggered twice. So basically, I'm going to run twice the same pipeline on the same code, which is obviously something I don't want to do. So you can be more, you can refine actually how you define those rules by using the rule statement. But that's more like a detail. Another neat thing is the definition of dependencies between jobs. You can use either the dependencies or the needs statement, and that's what will produce this schematic here, or where basically you can visualize which job depends on what, and doing so you can potentially accelerate your workflow. If you have multiple runners available, they will be able to distribute the task across them, but you'll end up having a faster job when you do that. Okay, very quickly, yeah, the final things here. You can define manual actions. This is something we thought was useful for anything related to actually doing something on the supercomputer. So if you want to avoid that any commit, or I mean, if you want to be able to have a better manual control on whatever you're doing on the supercomputer, you can do a manual test, and basically you will have to go into the interface and click on that play button for running anything related to the HPC. At least this is what we did. I talked already about multiple runners, and yeah, just to finish with the interface, the web interface. The nice thing about GitLab, and it's the same thing on GitHub. So when you have CI/CD implemented there, you have a visibility directly from the pull requests. You can see if the code that you're trying to merge is gonna pass the pipeline or not. And you have also a direct link to those tests that I was talking about. So giving you a more detailed view of what is working and what's not working for this specific merge request. All right. So yeah, I'm reaching the end of the presentation. Again, that was, I think, nothing too complex, except for the part of we had to figure out how we would handle the connection with the HPC. But basically, when you want to set up something like that for your code, the documentation is really the way to go. And you have, I'd recommend looking at the page that details all the things you can do in the YAML file, because it really gives you a good idea of how you can start. And obviously, you can also look at other examples. I've listed here some codes that I know of that are kind of well established and use pipelines. If you want to have access to FLUPS and the things that I showed today, feel free to send me an email. And yeah, the general takeaways that at least what CI/CD did for us is it saved us a lot of time. Of course, you have to spend some time setting it up in the beginning, but in the end, when you have multiple users working on the same code, and especially PhD students, you know, it's good to have some mechanisms to check for whatever you're doing, and that is really helpful.